Hello everyone. So this video is just to give you a little bit of extra assistance with writing equations. So we're going to look at one example that is from a table, one example that's from a list of numbers, and then one word problem. And we're just going to write the recursive and explicit equations for the situations that we're given. So taking a look at number one, we've got this table where we've got the figure numbers and the number of dots. So what I like to do is right away, I like to define what my variables are going to be, and I like to figure out which one's my input and which one's my output. So for my figure number, I'm going to call that F, and for the number of dots, I'm going to call that D. So I know that F is going to be my input, my figure number is going to be my input, and then the number of dots is going to actually be my output. So input, and then this one is my output. Then the next thing I like to do is figure out whether this is an arithmetic or a geometric sequence, and so I do that by finding the pattern. So if I know I'm going from 3 to 12, I know this is increasing, which means I'm either going to be adding or I'm going to be multiplying. So if I go from 3 to 12, if I was adding, that would be plus 9, but 12 plus 9 is definitely not 48. So then I'm going to try multiplying. I know that 3 times 4 gets me to 12, 12 times 4 gets me to 48, and then 48 times 4 gets me to 192. So I know that I'm going to have a multiplying pattern, and it's times 4. So then I always write myself a note also that this is going to be geometric, and I know that because it's a multiplying pattern. So I'm going to have a common ratio of 4. Alright, so now I need to write my recursive and my explicit equations. So I know for a recursive equation that the number of dots right now is the number of dots previously, so the previous number of dots, times 4, because that's my pattern. So if I want to talk about the number of dots that I have right now, that's going to be D of F. So the number of dots at figure F is going to equal, in order to talk about the previous, I know that that's going to be D of F minus 1. It's the number of dots in the previous figure, and then times 4. Now remember, this is only one part of our recursive equation. This is only telling me take the previous and multiply by 4. This is the pattern. We also need to make sure that our recursive equation tells us where to start. So if I look at my table, my initial start value was figure 0, and I had 3 dots, which means in order to write that, I'm going to say D of 0 equals 3. So what this means is if I input 0, I get an output of 3, so that tells me the starting value was 3. So remember, it has to have both of these parts. And my students, I even tell you sometimes to just number it because it helps you. So here's where my pattern is, it's the previous times 4, and here's where I started with 3 dots. Now for the explicit equation, I'm going to actually look at expanding my table so that I can figure out what this pattern actually is. So I'm going to go ahead and just extend this out a little bit. And I know that the way I got to 12 was by doing 3 times 4. In order to get to 48, I did 3 times 4 times another 4. I started at 3 and I multiplied by 4 once and twice. Then to get to 192, I start at 3 and I'm going to multiply by 4 3 times. Well, we know if we're writing out multiplication, or if we're writing out repeated multiplication, we know that we can rewrite that using exponents. So this is the same as 3 times 4 to the second power. This is 3 times 4 to the third power. And we know we can rewrite this one as 3 times 4 to the first power. So now what I need to do is figure out how does this help me write my explicit equation. I know my explicit equation needs to start with D of F. So I'm going to say the number of dots at figure F. And if I look here, I can see that each of these, when I expanded, started with a 3. Because that was actually my initial value. So there's the 3. Then I can see that my pattern here was multiplying by 4, and I can see that that's the base of my exponent. So I'm going to do times 4. And now I just need to figure out what's special about that exponent. So if I look, the exponent here is 1, and that was for figure 1. The exponent here is 2, that was for figure 2. And then in figure 3, my exponent was 3. So if I were to go to figure 4, for example, my exponent would be a 4. That means if I want to go to figure F, my exponent is just going to be F. And we know, since we're starting the table at 0, that this is just going to be F, because we're starting at 0. If we had started at 1, that's when we would have the F minus 1. But so this is your explicit equation for that. Let's take a look at number 2. So for number 2, we're given this list of numbers, and it says that we're starting at term 1. So I don't know about you guys, but for me, it's easier to find my pattern when it's actually in a table. So I'm going to go ahead and actually make a table. And I'm going to say term number, and I'm going to write out the values. So this says it starts at term 1, and term 1 is actually 2. So then my second term is 13, my third term is 24, and my fourth term is 35. So I'm going to do the same thing that I did on the problem above. I'm first going to figure out what my variables are going to be, and which one's my input, which one's my output. So my term number I'm going to call T, and for the value I'm going to call that V. I know that my term numbers are my input, and the values are going to be my output. Now I need to find my pattern, so I'm going from 2 to 13, so I'm increasing, which means I'm either going to add or I'm going to multiply. So if I go from 2 to 13, I know that that's kind of, let's see, that's adding 11, and then 13 to 24 is also adding 11, and 24 to 35 is adding 11. So plus 11, plus 11, plus 11. So if my pattern is adding, I know that this is arithmetic. And if it's arithmetic, I know that it has a common difference. And so the common difference is, we're adding 11, so the common difference is 11. So now I'm going to go ahead and write the recursive. I know that in order to get the value right now, I need to take the previous one, and I have to add 11. So if I want to talk about term T, then I know I'm going to talk about V of T. I need to take the previous one, which is V of T minus 1, because I want the term before it, so it's 1 less, and then plus 11. So this portion right here of the recursive tells me what my pattern is. But I have to remember, my recursive equation always has 2 parts. It has the pattern, and it also needs to tell me the starting value. So if I look back up at my information up here, I know that I started with my first term, and my first term was 2. So there's the 2 parts of my recursive equation. It's the previous plus 11, and then it's the starting at 2. Okay, in order to do the explicit equation, we're going to expand our table, and so I'm going to just kind of draw in some lines here to expand my table out. I'm going to go like this. All right, so to get to 13, excuse me, I did 2 plus 11. In order to get to 24, I know that that's 2 plus 11 plus 11. And in order to get to 4, I know that that's 2 plus 11 plus 11 and plus another 11. So I had to add my common difference 3 times. All right, so for my explicit equation, I know that I'm going to do V of T. Remember, T's our input, so it goes inside the parentheses. V's the output, so it's outside the parentheses. If I look, each of these started with a 2, and that was my initial value. Then I can see I'm adding 11, and the thing that's changing is just the number of times I'm adding 11. So I know that this is going to be 2 plus 11, and I just need to figure out what's special about the number of times I'm adding 11. We know if we're writing plus 11 plus 11 plus 11, we can rewrite that as multiplication. And so I can rewrite this as 2 plus 11 times 2. I can rewrite this as 2 plus 11 times 3. And this one is just 2 plus 11 times 1. So what we need to figure out is what's special about that number of times we're adding the 11 or multiplying by 11. So we know here, when we're multiplying 11 by 1, that was for term 2. For term 3, we're multiplying by 11 twice. For term 4, we're multiplying by 11 3 times. So if I look, it's always 1 less than my term number. So if I were on figure 5, then I would be multiplying 11 by 4. So since I want to figure out what I'm at for term t, I know that I'm going to do 2 plus 11, and it has to be multiplied by 1 less than the term number. So the way we write that is t minus 1. So that means inside these parentheses here is going to be t minus 1. Since my table started at 1, it makes sense for my explicit equation to have that t minus 1. Okay, now we've got one word problem that we've got to go through. All right, so Jack started saving for a new phone. He only has $40 in his bank account. On the first week, he deposited $35 and plans to continue depositing $35 a week. So there's a few things we've got to worry about here. So it says that he only has $40 in his bank account. This is what he started with. On the first week, he deposited $35, and he plans to continue depositing $35 a week. So when I read this, to me, it seems like this 35 is what's giving me this pattern. So if he's starting with $40 in his bank account, I'm going to say that that is really week 0. We're starting at 0 because after the first week, he's deposited another $35. So I'm going to make a table to kind of organize my work here. So I'm going to say weeks, and I'm going to say the amount of money in his account. So we're just going to put money. So when he starts really at week 0, he's got $40 in his bank account. After the first week, he deposits $35, so I know that this is going to be $75, which means on week 2, he's going to deposit another $35, which is going to get me to $110. So we can see each week we're adding $35. And so this is an arithmetic pattern. And we have a common difference of 35. So we're going to do the same things that we did before, and we're going to define our variables and write our equations. So I'm going to call the week W, and I'm going to call money M. So for my recursive equation, it's going to be M of W equals the previous, which is M of W minus 1, plus 35. This tells me my pattern. And then I need to figure out where I started, so that's going to be M of 0 equals 40. For the explicit equation, we know it's going to be M of W. And I know that Jack started with $40 in his account. So I'm going to put 40 plus my common difference, which is $35. And I just need to figure out what is this 35 multiplied by. So I'm going to just make a note really quickly here. This was our start. This was the common difference. And we just need to figure out how many times is he multiplying by 35. So in this very first week, he added 35 once, and in the second week, we'd add 35 twice, which means that the number of times he adds 35 just depends on the number of weeks. We started at week 0, so this is just going to be W. If we started at week 1, this would end up being W minus 1. All right, hopefully that makes a little bit more sense. Now you've got at least 3 examples that you can look back on to help you. You're going to work on some practice and talk to your teacher if you need some more assistance. Thanks for watching.